Welcome to the online lecture video, and today we are going to see the topic universal shift registers. So in previous topics we covered what is registered, what is how we can be usage of the data information, the registers we call it the shift registers. Okay. Now the next step we are moving to the topic universal shift register. So this is the whole diagram of universal shift registers. So we can say there is a whole assemble of shift registers. Actually, we already seen the previous lecture. There is a four type of shift registers are available: serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. Right? Yes, and also the based on the axis of shifting, we can categorize as unidirectional and bidirectional. So most of the shift registers and all the shift registers, not most, all the shift registers are used as unidirectional shift register, and this is the one where whole summation we used here. This is called as bidirectional shift registers. So we can able to see that, okay, the four flip flops we used here, and before that, along with that, okay, in the diagram there is an four multiplexers are also used. So we already seen the previous lectures what is multiplexer, what is demultiplexer. So we can check it, okay, in our channel. The multiplexer was linked and forward to the consent flip flop, okay, to activate the four kind of activities in a single circuit. Okay. The right side, this is the IC pin diagram. So clear pin is there, and the two selection lines are there, and shift input left indicator, shift right, shift input right indicator, and the four type of parallel input IA, IP, IC, ID, and QA, QB, QC, QD. These are under output, parallel output. This is the parallel input. This is the serial left. This is serial right. So parallel in, parallel out, serial in, serial out, parallel in, serial out, parallel in, parallel out. So four kind of types of shift registers we can perform in the single circuit. So by this way, see the diagram. So how the importance of multiplexers in the universal shift register. Okay, so before that, so this is the why we call it as bidirectional shift register, and so this is the definition. So the operation, the capable of shifting content either left or right depending upon the signals presenting an appropriate control input lines. The control input lines represents here, okay. So here the four kind of lines are there, and mode control SISO. This is the mode control input lines. So here in multiplexer, the purpose of this selection line is, okay, so we can select the data what we want, the receiver what receiver needed, okay. So here same thing here also. So what the multiplexer output is depend upon the these selection lines. Yes, and based on this only it will act as a bidirectional, which way left to right or right to left, like that it will do. So universal shift register is depending on the signal values on the selection lines. Already told just now we discussed. Okay, so let me see one by one of the multiplexers. The registers can retain its current state, shift right and left, or be loaded in parallel. Each operation is result of the edge triggering here. So I'm using here the edge trigger clock pulse. Let me see. So this is the edge trigger clock pulses, and clear button are used. If you need it, you can use the preset also. I didn't mention it here. And the clock pulse, synchronous clock pulses I'm used. And let me explain it the multiplexer operation here. So there is a two selection lines and four input lines, one output. There is 4:1 max. There is a two selection lines. So this is the two selection lines helpful to find the which one, the apart from the four input line, which one will be give as an output. Okay, and the four I naught, I1, I2, I3. So likewise, there's four muxes are used in the circuit, and I naught and I1 represents, see that the I1 represents serial input for shift right. So this is the pin responsible, this is the pin responsible for shift right operation. And I2 is the pin, it is the responsible for serial input for shift left. Okay. So this is the meaning, and the I3, in that I1 we see I2, and I3 represents the parallel bit input, and that I naught was connected here. See, I naught was connected here for that output of the flip flop, and connected to the next multiplexer of the input. Likewise, it is going. So these four input, one is shift right responsible, another one is shift right, and the third one is for parallel input, and the first pin it is responsible forwarding the output to the next multiplexer, and the output is fetched to the input of the concerned flip flop, and the whole summation, the whole circuit will act as a universal shift register, that is called as we called universal one, because all the operations will perform in a single circuit. Let's see the basic connection. So this is the basic connection I used here. The operation of selection line is 0 0 0 1 1 0 1. If it is 0 0, there is no operation will perform, it making us a delay or like as a memory hold on operations. If it is 0 1, represents S naught is enabled, the whole operation, the register operation will perform as a shift right, and 1 0 represents shift left, and 1 1 represents parallel load operation will perform. So this is the thing I may make a statement here. So the first input is connected to the output pin of the corresponding flip flop. This is the basic connection of what we seen in the multiplexer. Zeroth pin of the multiplexer is connected to the output pin of the corresponding flip flop, and the first pin of the multiplexer is connected to the output of the previous flip flop, which facilitates the right shift, and the third input for facilitate the left shift. Fourth input is a facilitate for the parallel loading process. Okay, and this is the selection lines importance. Okay, and this is the working operations of selection lines. Based on this only, it will act as a shift right, shift left, or parallel load, and it make it as an ideal condition depending upon the input given to the selection line. Yes, then what is the advantages, pros and cons? Advantages is we can say four type of operation will do in a single uh, circuit. So because of multifunctionality, left and right shift, parallel, static, code can be performed, and flexibility also. So we can use in many different platforms, in digital platforms, and we can easily identify that we can be able to reduce the hardware is involved in the circuit. It is more efficient one compared to that point of view. And what is the disadvantages? We can say the complexity of the circuit comparable with the previous simple shift registers. This is more complex and expensive, and if this complexity if increases, automatically the operations will become a slower one, because of additional logic, additional controls will make them it is slower and higher cost. Whenever the functionalities and operations increase, functionalities increases, the cost wise also possibly it will increases. So the implementation cost also will high. Applications, main applications of um, universal shift register is signal processing and data serialization or parallelization. That is the thing. Okay, where communication data can be in the communication systems. The data can be transferred from the parallel format or serial format, and it's a digital signal processing by interest application in arithmetic. We are dealing the data and manipulations, and we can use the one operation 0 0 means we'll make it as a hold, so that it the purpose we can introduce the delays in wherever the circuit is necessary. And this is the thing we can able to control and append lower frequency clock signals. And the main application it was counters and timers. This is the most thing. Okay, we will see in next one, counters. So this is the only it performs the counting operations. So this is the most predominantly applications. Let's see the counter, because for better understanding of shift registers and universal shift registers, we should know what is counter. Counter is an example of register actually. Yes, we are all know. I hope to understand what is shift register, universal shift register. The whole application of registers we use as a counter only. The counter, it counting the process. Okay, counting the process. Yes. So the primary purpose is specified output pattern sequence. This is called as pattern generator, and it can be able to store 0 or 1 combination. The counter stores. That is because again we are using the flip flop here only. The total number of state is called as modulus. So the term modulus represents that derivative is m. There is a m distinct states, that is called as mod m counter. Mod m. So mod m is modulus m. Okay, so that is called the state of the counter. That is called as number of states we are used in the particular counter. And counting the sequence, the order in which state appears is referred to as counting the sequences. Based on the counting the sequences, we can depict the graph directly. This is the graph we call as a state diagram. Let's see the operation of the counter. Here I am trying to explain for understanding the register is binary ripple counter. The binary 4-bit binary ripple counter. The ripple counter represents asynchronous counter. The clock pulse, like we can see the asynchronous counter circuit here. The clock pulse is output of the previous one will be fetched as a clock pulse of the next one preceding flip flop. So this is called as asynchronous counter. Clock applying clock is different. And here I'm using the toggle flip flop, T flip flop. Yes. So this is the counter 4-bit binary counter 1, 2, 3, 4. It's a 4 flip flop 4-bit, and the input I'm giving is a T. Okay, and I put to get it as a Q0, Q1, Q2, Q3, and the Q bar output will be fetched as a clock pulse of the preceding one, preceding flip flop. Let's see. So the Q0, Q1, Q2, Q3, 0, 0, 0 initial state, and the 1 will come, and then again 1 will come, and again 1 here. So automatically it will be start increasing by based on the counting operation of the toggle. So the previous one is 0, the next one will be the 1. Toggling happens. If you maintain the same, the toggle will not happen. Whenever the output changes, the toggle condition will happen, will occur. So this is the counting. You can see the counting sequences, and this is the counting pulses. First pulses, the Q0 activated. The second pulses, Q0 activated. Q1 is up to the second pulses will activated. The Q2 is up to fourth clock pulses will be activated. Q3 is up to the eighth, after the eighth clock pulses. It will be toggled conditions because of here the flip flop I'm used here. It is toggle flip flop. Whenever the toggle condition of the previous input, the next state will be act as a new one, new state will come. So for here for Q1, so Q0 will change up 1 to 0, the output was changed from 0 to 1. For Q2 1 to 0, the output was changed to 0 to 1. For Q2 1 to 0, the output was comes Q3s was changed here. So this is the logical diagram, sorry, uh, timing diagram of the 4-bit triple counter. And this is the explanation of those things, and how we can use as the counters based on shifter one. So this is the diagram I'm trying to say. See the counting of 0 qa qb qc qd. So parallelly I'm taking the output at the same time. So giving the input as d, first bit only enable, that one will be passed to the next one upon giving the clock second clock pulses. For third clock pulse, the one should be forwarded to the next one. Fourth clock pulses, this will cover to the fourth one. So likewise, again the fifth one automatically it comes to the first one. Likewise, see the diagram. First clock, second clock, third clock, fourth clock, fifth clock again comes to the first position. So there is a 4 counting is there. This is called as a ring counter actually. So there is not efficient in number of flip flops used but provides a decoded output. This is the counter. Yes, so the counter I'm explaining here for better understanding of shift registers. So I hope to understand the shift registers. We can see the next videos on Linux registers. Thank you.